have done in our videos, units and dimensions, and relevant past paper questions also. Okay, now we are going to start the scalar and vector quantities under physics grade 12 syllabus. Okay, first one is introduction to physical quantities. The physical quantities are measurable properties in physics. They are classified into scalar quantities and vector quantities. The physical quantities are measurable properties in physics. They are classified into scalar quantities and vector quantities. Okay. So what is scalar quantities? The definition says a scalar quantity is fully described by its magnitude only. The scalar quantity, it has only the magnitude. It's fully described by its magnitude only. So there are no directions involved. No directions involved. For an example, if you take mass of a unit or mass of a thing, it doesn't have direction. It has only the magnitude. If you have a time, also only the magnitude. There is no direction. If you take a distance, you may know the distance is not a vector quantity, it's a scalar quantity because it doesn't have a direction. Pressure, energy, density, and speed, area, volume, work, power also are examples of scalar quantities. Okay, but the tip for the students is scalar quantities can be added using simple arithmetic. We can add one mass to another mass just by a simple arithmetically. Okay, so no need to consider the directions and the other concepts. So just we can add it with the using a simple arithmetic. Vector quantities, what definition says? A vector quantity has both magnitude and direction. You may study it in this in all level also. So anyway, we will remind this one in advanced level prior to go for the deep discussion. So the definition of the vector quantity has both magnitude and direction. So direction is matters, and they follow the law of vector addition. Okay, so we will see what is vector addition, how we can add the vectors. Okay, so they're following the vector additions. Examples: displacement. Displacement is a vector quantity. Velocity also a vector quantity. Acceleration also vector quantity. Force, when we use the force, we have to mention the direction. Also the acceleration, we have to mention the direction. Velocity, if you talk about the velocity, also we have to mention the direction. But if you talk about the speed, we will not mention the direction. But in the case of velocity, we have to mention the direction because velocity is a vector quantity. And also momentum, impulse, and magnetic flux density. Magnetic flux density, not the density, magnetic flux density and weight are all are examples of vector quantities. Tip for the students: you must consider both the direction and magnitude when adding vectors. When we adding vectors, but in the scalar quantities only you have to consider, you have to use the simple arithmetic formula, simple arithmetic calculations, you can add the magnitude of the scalar quantities. But in the case of vector quantities, you have to consider both. You have to consider both direction and the magnitude when adding the vectors. Okay, right. The fourth one is geometrical representation of a vector. Geometrical representation of a vector. Let's say a vector shown as a directed line segment, an arrow. For example, you see a vector, we can show a segment. Let's say AB. Okay. A vector is shown as directed line segment. It's an arrow with an arrow. It means the length of the line is the magnitude. The length of the line is magnitude. That the length of the line, we can say mod of AB, means it is the length of the line. Length of the line. Length of the line, let's say L. Yes. Let's say L, the mod of AB, or the magnitude of the vector AB is L. Magnitude of the vector AB is L. The arrowhead, this arrowhead is showing the direction of the vector. The arrowhead showing the direction of the vector. Whether we can say with the horizontal this much theta, or whether we can say vertical this much theta. For example, if you take a vector like this, okay, we can say this vector direction is with the horizontal theta. Okay, with the horizontal theta. Likewise, we can mention the direction. So that arrowhead is showing the direction of the vector. Okay. So the vector from A to B, we can say AB vector. Say AB vector, or in case A vector, or otherwise we can say A vector like this. Okay, A vector. So the magnitude is mod of AB. Magnitude is mod of AB. The length of the AB. Let's say we can say the length of the AB is L. Okay. So this is the simple geometrical representation of a vector. Let's say, what is equal vectors? What is equal vectors? Yes, there are cases where line AB, okay, line AB, that's the first case, okay? It's the first case. This is the first case. Line AB and the line CD, sorry. Line AB and line CD, line, yes, CD are in same line, okay? Means same line, meaning what? Same direction. AB and CD are in same line, same axis of line, okay? Means both are having the same direction. Also, the length of the AB and the length of the CD are equal, means the vector AB and vector CD are equal. Meaning what? The magnitude and the direction should be same. So if the two vectors are in one line or in one direction, okay, one line means it's in one direction. Yes. So that is the case. If the AB vector of AB, the magnitude of the AB and the magnitude of the CD are same, means the vector AB and the vector CD are same. That means vector A and vector B are same. Vector A and vector B are same. Because AB vector, direction of the AB vector and the direction of CD vector also same. Also the magnitude of AB, magnitude of vector AB and the magnitude of vector CD are same. Magnitude of vector AB and the magnitude of vector CD are same. Also the direction. Hence, vector AB is equal to vector CD. So these two are equal vectors. In this, these two are equal vectors. In other way, in other option, okay, there are two vectors are parallel. There are two vectors are parallel and having the same magnitude, okay? Let's say a vector AB the vector AB is parallel to vector, so it's length is high, no? The parallel to vector CD. Okay, the vector AB is parallel to vector CD. Both AB and CD are parallel vectors. Okay, parallel vectors. At the same time, mod of AB, the length of the AB and the length of the CD both are same. Both are same. It means mod of AB vector and the mod of CD vector both are equal. It means parallel. The magnitude is equal and also the direction is equal because those are parallel vectors. So the directions are equal, same direction and the magnitudes are equal. Hence, in this case also, we can consider like if the magnitudes and the directions are same, so there are two vectors can be equal. So equal vectors are AB vector and the CD vector. One case, both two vectors are in one line and the same magnitude, or the two vectors are parallel and same magnitude. Okay. Okay. Then what is there's a case two, the opposite direction or same magnitude. Opposite direction and same magnitude. Let's say if a vector AB, if a vector A vector, okay, let's say AB, okay, and the vector CD, the CD vector is opposite to the AB vector. You can see the arrowhead is showing the opposite directions. Opposite directions. It means the arrows of the same length but opposite directions. So this case, we can say the AB vector is what? AB vector. So to change of the direction, we can say minus AB vector, whether AB vector is equal to minus CD vector. It cannot be CD vector because we have to change the direction now. We have to change the direction. To change the directions, we have to use the minus symbol because it's negative. Because in this directions we are using positive. So it means if we want to change this direction to other, we have to put the minus symbol. It means AB vector is equal to minus CD vector. In other way, CD vector, if you take a CD vector is positive, okay, CD vector's direction is positive means CD vector is minus AB vector. CD vector is minus AB vector. So the opposite directions, if you change the directions opposite, we have to use the minus symbol. Okay, the arrowhead. If you change the arrowhead, we have to use the minus symbol. So if the magnitudes are same, the vector magnitudes are same, but the direction is different. Different direction is opposite. Hence, we have to use the minus symbol. That is, AB vector is equal to minus CD vector. Okay. The second lesson plan is addition of vectors. Second lesson plan is addition of vectors. This learning objectives are the students can add vectors using the parallel vector method or understand and apply vector triangle method. Okay, parallel vector method or vector triangle method represent vector addition graphically. Okay, represent vector addition graphically. Okay, under this lesson, addition of two parallel vectors. Addition of two parallel vectors. Let's say there is a vector A is 5. The magnitude is 5. The direction is 5. Direction is like this. Okay. And the same direction, there is another vector. The magnitude is 3. Magnitude is 3. So the resultant vector also parallel to both. also parallel to both, this resultant vector supposed to be what? 5 plus 3. Why? Because we can add using small algebraic arithmetically we can add these two vectors simply. Why? Because both directions are same. Both directions are same. Then we can add this the resultant vector results. Just we have to add simply. It's called 8. The magnitude of the resultant force is 8. Okay, the direction is same. The direction is same. Let's say if the two vectors are opposing each other, means, okay, let's say this is 3. So the resultant vector in this direction, suppose what? R. R is equal to 5 plus minus 3. Why? Because we are using the resultant vector in this direction. Okay, let's say I'm explaining again. So there's a 5 vector in this direction. One vector is opposing to 5. It's 3. Vector magnitude is 3. So the resultant vector is which direction? Supposed to be should be this direction. That's called R. Okay. So since I'm mentioning the resultant vector in this direction is positive. It means vector R is equal to what? 5 is in same direction. So, okay, same direction. But this 3 plus this 3 vector is opposite direction. It means what? Minus 3. Minus 3. Minus 3 in this direction. Okay. But plus 3 other direction. If you take plus 3 in this direction, since I have changed the direction minus, so I can convert the direction to the resultant force direction. So minus 3 directions. It means what? R is equal to 5 minus 3, 2. The magnitude is 2 in this direction. In this direction, R is equal to 2. Okay? Right. Then arrow points show the direction and add up. Okay, tip for the students. Just like adding lengths on a straight path, direction must be the same. Direction must be the same. If the opposite directions, you have to use the sign convention. Sign convention. If you're using, if you are taking the resultant force, a particular direction means that direction you have to take positive. That directions you have to take positives. Opposite directions are negative. Otherwise, if you take other direction, that directions you have to consider as positive, and other opposite directions you have to consider as negative. So sign conventions you have to consider when adding two parallel vectors. When adding two parallel vectors. Okay. Vector triangle methods. Vector triangle method. Okay. If two vectors are placed head to tail, what do you mean head to tail? Okay, let's say a vector AB. Okay, AB. Since the arrowhead is in this side, mentioning this one, this is called head. Head of the vector. This is called tail of the vector. Okay. Because why? The direction shows in this direction, the arrowhead showing this direction. So this one is the head of the vector. This one is the tail of the vector. Okay. If two vectors are placed head to tail, the third side of the triangle from the start point represent the resultant vector. Okay, means if the two vectors are placed head to tail, okay, one vector what? This is AB vector. This is AB vector is here. This is tail. This is head. This point is head. This point is tail. Okay. Another vector, it's placed head to tail. Means what? From head of this vector, head of this vector to another vector. This is okay. This is head of the other vector, but two vectors are placed like this. Okay. Two vectors are placed like this, but placed head to tail. Head to tail. AB vectors, tail is this one, head is this one. But BC vectors, tail is this one, head is this one. Okay, head is this end, and the tail is this one. Okay, these two vectors are placed head to tail, head to tail, head to tail. This head, it's connected to tail of the BC vector. AB vector's head is connected to BC vector's tail. That is the meaning of these vectors are placed head to tail. Vectors are placed head to tail. Hence, okay, in this case, if we place two vectors, the third side of the triangle, the third side of the triangle is what? This one. Yes, third side of the triangle is this one. This is the resultant vector. This is the resultant vector of what? AB vector and the BC vector. AB vector and the BC vector. Let's say this vector is A vector and this vector is says B vector. Then the resultant vector is called what? A vector plus B vector. Only we can add. We have to add with the direction. The resultant vector, we have to add with the direction, not R plus R is equal to A plus B. The magnitude, it not necessarily mean if the R vector is resultant vector A vector and B vector means not necessarily mean the mode of R or the magnitude of R is A plus B. It is not necessary. It is not the meaning of that one. So we have to. This is possible where the vectors are same direction. Where the vectors are same directions, we can use this formula. But here the directions are different. Directions are different. So we have to use the parallelogram theory that we will discuss later. So in this case, vector R vector is equal to A vector plus B vector. R vector is equal to A vector plus B vector. Okay, right. We will see how to solve this kind of problems and this kind of vectors, how we can add. But in the vector form, we can say the R vector is equal to A vector plus B vector. Okay. Come to a quick check questions. What happens if two parallel vectors points in opposite directions? In opposite directions means what happened? So we have to use the sign convention, or if you take this direction positive and this directions we have to consider as negative. Okay. Okay. Use triangle method. If a vector A is equal to 4 unit east, means in east it has magnitude, the vector is 4. Okay, vector is 4 and the vector B is equal to 3 in north. So it is connected like head to tail. Okay, it means what? This one is, this should be what? By the Pythagoras law, it is 5. By the Pythagoras law, it is 5. Okay, sketch and find the resultant. So what I have to do? We have to even the, let's say if it is R, okay, as we already told, this is R, no? This is R vector is equal to what? Vector 4 vector plus 3 vector. R vector is equal to vector 4 vector plus 3 vector. Okay. It means what? Vector 5. Okay, but having the different directions. Having the different directions. But you cannot simply say 4 plus 3, 7. Okay, but using the Pythagoras theory or the parallelogram theory, we have to add these two vectors in this case. Okay. Okay, then the magnitude is 5. The direction is what? Tan theta 3 over 4. Tan theta 3 over 4 means theta tan inverse 3 over 4 with horizontal. The direction is theta tan inverse 3 over 4 with the horizontal or with the east. Okay, the magnitude is 5. That is the resultant vector. That is the resultant vector. Okay, state the difference in the result when vectors are added head to tail versus tail to tail. Head to tail method is we have seen, that is the vector triangle method. That is vector triangle method. That's what we have studied. Okay, head to tail. Head. This is tail. This is head. Okay. If you take a vector, this is tail. This is head. Okay. The arrow head is showing which end is head, and other vector is placing tail. So vector head to tail. So tail should be continue. So with the continue with this vector, tail vector should be continuous. So tail of this vector, it is connected with this head of this vector. Okay, head of AB vector, okay, connected with the tail vector, BC vectors tail. BC vectors tail. Head of AB vector connected with the tail of the BC vector. That is head to tail addition. Head vectors added or placed head to tail. What happened? Tail to tail. What happened? Tail to tail. Tail to tail, it's having, okay, let's see. How it will be tail to tail means? Okay. Tail to tail means this is AB vector. Okay. This is AB vector. This is tail. This is head. This end is head. This end is tail. This is AB vector. But with this tail, another tail will be continue. Another tail will be continue. It means what? Like this. So AC vector. So this tail is connected with the AC vector's tail. Connected with the AC's vector's tail. In this case, we have to use the parallelogram theory. This theta is difference means what will happen? The resultant force in this directions. To find this resultant directions, we have to use the parallelogram theory that we will discuss later. Okay. So we will see the answer head to tail and the tail to tail vector addition. Head to tail methods are the correct addition. The second vector start from the head of the first vector. That's I already described. The resultant vector is drawn from the tail of the first vector to the head of the second vector. Head of the tail of the first vector to the head of the second vector. This method gives the correct magnitude and the direction of the sum. It visually represents vector addition. Visually represents vector addition. Okay. So only for the vector additions, you have to, in this case, what you have to do now, for an example. Okay. Yes. Head to tail, what you have to do is, let's say, geometrically only you can find the results. Okay, 3 vector is here. Okay, you have to measure 3 vector in this direction, east direction. and another vector, it's 4, let's say with an angle. Not the earlier we see that these are east and north, that is separate, but here it's having a theta angle, okay, with the theta angle, not the north. Okay, this case, this angle is 4. Then what? How we have to find the resultant vector? It's not equal to 5. The resultant vector, it's not equal to 5, and direction also different. Okay. So this case also you have to calculate this resultant vector by geometrically. By geometrically only you can calculate. Okay. So this case you have to use what? Geometrical formulas, and you can use the resultant vector. Otherwise, vector polygon method you can derive. Okay. You can measure and draw. You can measure, or by scale you can draw the vector 3. Vector 3. Okay. And from this point, from head to tail, no? So from this point, this theta, okay, measure the theta and draw the line 4. And then draw the line 4. This is vector polygon method, okay? Vector polygon method or triangle method. So by geometrically, you can draw this line by scale, okay? Then you measure this line. Then you can measure this line is the resultant value, the value of the resultant force or the magnitude of the resultant force. So this theta you can measure in the by scale. Okay. So by geometrically also you can find this. Otherwise, by using the formulas, you can derive the resultant force and the directions. Okay. So what happened? The tail to tail method. Tail to tail method is, as I showed you earlier, these two vectors are connected with tail to tail. These two vectors are connected by tail to tail. Yes. Let's say vector AB and the vector AC. The arrowheads are starting from A. So the tail to tail, both vectors, tails are connected. That's means tail to tail. In this case, we have to draw a parallel vector to this. Okay, like AC vectors, let's say C dash. Let's say C dash. Now what happened? Now what happened? As per the triangle rule, we can derive this one, this resultant vector. Okay, this is the vector parallelogram theorem. So for this, to derive this one, we have to calculate a formula. We have to derive a formula. Let's say this is theta. Okay. Okay, we will discuss this the formula and the next chapters. How to, or in the mechanics, we can derive the formula of parallelogram theory. So in this case, you have to, what happen is tail to tail, adding of tail to tail vectors, you have to consider the vector parallelogram theory. But if you have the vectors are placed head to tail, we can use the triangle method. Triangle method. Okay. Yes. So we cannot directly add. So what's the meaning of the use to head to tail for direct vector additions? Tail to tail need an extra step, that is parallelogram rule, to find the resultant. To find the resultant. Okay. Parallelogram law and the resolution of vector. Parallelogram law and resolution of vector. Understand and apply parallelogram law of the learning objectives. We will understand the parallelogram law and the vector addition, and we will explain the resolution of a vector into two components and interpret vector diagrams for addition and resolution. Okay. Okay. Parallelogram law of vectors. Okay. When two vectors are represented as adjacent side of the parallelogram, that means what happening? Let's say a parallelogram is showing like this. Okay. This direct this one, and this is parallel to this one, and this is parallel to this one. This is parallel to this one. This parallelogram we will call ABCD. ABC. Okay. When two vectors are represented an adjacent side of a parallelogram, let's say vector AB we call A vector and the vector AD we call B vector. Okay, from that diagonal represents the resultant. The two vectors are represented an adjacent side of the parallelogram. The diagonal represents their resultant. The diagonal represents their resultant. Yes, that is vector A and B. So this is the diagonal is the resultant for by a vector. This is if we say this is vector C. Okay, if we say vector C, the vector C is what? This is B vector. This is parallel to this one, and the magnitude is also same. So we can mention this also B vector. By vector triangle, we can say vector C is equal to A vector plus B vector. A vector plus B vector. Okay. So the vector A and B for the adjacent sides, the diagonal C is the constant. Okay. So to determine the magnitude and the directions, we have to use the geometrical formulas. Okay. So we will discuss how to derive the geometrical formulas later. Okay. Okay. So lessons how to resolution of a vector into two perpendicular components. Resolution of a vector into two perpendicular components. Okay. In this case, resolve a vector into horizontal and the vertical components. Use trigonometric functions to find the components, and we'll understand the geometric means behind vector components. Okay. So why this is useful, we will see later. Okay. What is vector resolution? Let's say what is happening if a vector, okay, if a vector, already we saw an example, if a vector 3 vector in the east and the vector 4 is in the north. So to determine in this case, because this is east and north, so perpendicular to each other, okay, perpendicular to each other. So there's a rectangle. There's a rectangle is formed. So the resultant force, what? To find the magnitude of this resultant R by Pythagoras theorem. So the resultant is 5. Resultant is 5. The direction is, we can use the trigonometric formula. So tan inverse what? Tan inverse 3 over 4. 4 over 3. 4 over 3. That is the direction of theta. The theta is tan inverse 4 over 3 with the horizontal. So that is the resultant force magnitude and the direction. Magnitude and the directions. Those we can derive by geometrically. But by vector additions, we can say R vector is equal to what? Vector 3 vector. So first coming 3 vector plus 4 vector Okay. So what is the meaning here? Actually, this vector, resultant vector 5. Okay. This resultant vector 5 okay, let's see. This is the resultant vector. Okay, determine resultant vector is 5. Yes, this resultant vector 5 can break like this. One is 3 vector, other one is vector 4. 4 vector. One is 3 vector and 4 vector. 3 vector east and the 4 vector north. we can break. We can break. The solution is breaking a single vector into two mutually perpendicular components. Mutually perpendicular components. Usually, we are using horizontal and vertical, but this any directions we can consider as a base of this vector, but these two components should be perpendicular to each other. These two components should be perpendicular to each other. For an example, okay, let's say, okay, let's say a force is acting like this. Okay, we are having, okay, let's say, okay, a slope is like this. In this slope, there is a mass m is there. Okay, there is a mass m is there. So what happened here? The weight will be act vertically. Okay, let's say mg. This one is, let's say, the slope is theta. The mass is placed over on the slope. The slope is having an angle theta with the horizontal. An angle theta with the horizontal. So this case, this mg, okay, we can resolve, or we can break to this mg. Let's say this is mg is the resultant force. This mg we can break into two. First one is, okay, this one in this direction. So this actually this mg is in this direction. No, means what? Both are should be tail to tail. Means in this direction one force, and the parallel to the slope also we can derive. Okay, parallel to. So let's say this is m1g. This is m2g. Okay, but this broken two components should be perpendicular to each other. So one component we have to perpendicular to the surface we can assume, and other one parallel to the surface we have to get. So if you take theta, this is what? 90 minus theta. This means this is 90 minus theta. Okay, this is 90 minus theta. This is theta means this is 90 minus theta. Likewise, if you take one vector, okay, don't get much confused. We will, when we are doing the exercise, we can get clear much better than this all. So simply say, okay, when a force, okay, when a force is acting with horizontal theta, okay, when a force is acting with the theta, it's called R, okay. When the force is acting with the horizontal theta R, then this R we can derive, or we can separate, or we can break two components perpendicular to each other in any direction. In any directions. Usually we are getting horizontal and vertical. Usually we are getting horizontal and vertical. So in that case, if you take horizontal components of this is what? R cos theta. Horizontal component is what? R cos theta. And the vertical components is what? R sin theta. Vertical components is what? R sin theta. Okay. Okay. Understood. Understood? I think you may understood. So vector R is inclined at an angle theta to the horizontal is called phi. Okay. So the using the basic trigonometry, the horizontal component is what? R cos theta. What happened is actually when it is acting, the force is acting R. Okay. Force is acting R. This is theta with the horizontal. So the horizontal magnitude of the what? This is the horizontal magnitude. This is the Okay, this is horizontal magnitude. This is the vertical magnitude. So magnitude of this horizontal is what? R cos theta. Magnitude is what? R cos theta. What about this vertical magnitude of this vertical? R sin theta by the trigonometry. Okay, by trigonometry is R sin theta. Okay, right. When we are doing exercises, it's my suggestion. Okay, because if you have different plans and directions and angles, sometimes they will give with the horizontal this theta and vertical this theta like that. Okay, so you will get confused. Let's say, for an example, if you take two forces are like this. Okay, one forces is here R. Okay, so let's say the theta is given vertical, not the horizontal. Then you will get confused. Okay, which one is cos theta? What one? Okay. If you want to make this, if you want to break this resultant force of the, if you want to break this force to a vertical and horizontal, okay, only consider the angle between the that force and the vertical. Angle between the force and the vertical. So what is the angle between the force and the vertical is theta. So just put R cos theta. R cos theta, because this theta you have to mention here. Okay. No need any confusions. What is the angle between that which directions you are going to break this force? Okay, and you consider that angle only, that angle, consider that angle. Let's say it's theta, means you can break that force r cos theta for that time, that direction. Means which directions you are going to break, and the force acting in between the angle, you have to directly consider as r cos theta. Okay, so what about this one? Now don't make it the angle. So here also, what is this angle? 90 minus theta. Okay, this is what? 90 minus theta. This angle is what? 90 minus theta. So you simply write, you want to this direction, no? You want to horizontal directions. You put cos. Cos. What is this angle? Don't put the theta. Put 90 minus theta. We are using cos always. If you are using the cos always, okay, remember that angle should be consider the direction and the force. The angle you have to put here only the angle in between the direction and the force. Direction and the force. Which directions you want to convert that force, that direction and the force, the angle you have to consider. Okay. So any case you can put, let's say, okay, R, then what? Cos 90 minus theta is what? Sin theta. Cos 90 minus theta is what? Sin theta. So if you know the angles clearly, then what? Let's say, okay, let's say like this. Okay, let's say a force is acting with 60 degrees, 60 degrees horizontal. Okay, let's say 5 vector force 5. Vector 5 is acting with horizontal 60 degrees. So what are the resolutions or the break components in horizontal and vertical of this vector? Of this vector means, as I told you, okay, you have to get this vector in this direction, this components, this vector component in this directions. Let's say 5. Don't think sine or cos or whatever it is. just put cos. Okay, just put cos. Which directions you want to get? This direction. Okay, what is the force acting direction? This one. Okay, in between this direction and this directions, what is the angle? That is 60. Okay, directly put 60. So 5 cos 60, it's in this direction. Okay, then what is the vertical component? What is the vertical component? Vertical components, what is the angle? It's 30 degrees. It is what? 30 degrees. Okay, now what is the vertical component of this? This is the resultant force 5. Don't think cos or sine, only put cos. Okay, you just put cos. Okay, now consider the angle. Which angle you have? Which angle you have to put? 60 or 30? Yes, you must put 30 because you're using the always you are using the cos means the angle between the force and the directions where you want to make it component. Okay, so you are making this force vectors component vertically. So the angle between the vertical and the force acting directions you have to consider. So that is 30. Okay, that is 30. So that is you put directly cos 30. So the horizontal component is 5 cos 60 and the vertical component is 5 cos 30. Okay, so no need to make confused which one is sine or cos or something like. Always use cos, but when you're using this concept, you have to consider the angle between the force acting and which directions you are making this component. Don't need to get much complications and confusions. Only use cos. Put cos and determine the angle and put that angle directly. Okay, that is very easy. Okay, that's what I am saying. You see here, this one also we can say the same concept. No need to use, but what the angle is this one? This is 90 minus theta. Okay, 90 minus theta. Okay, this is theta. So this component, what is that? R. Directly you can put cos. What is the angle between this and this? Is theta. So cos theta. The horizontal component is r cos theta. This is correct. So what is the vertical component? You can see r. You put cos. You put cos. Okay. Don't make it confused. You get sine or whatever. No need. So only the resultant force, the force acting this one. Okay, this directions. You want to make it this component into this directions. What is the angle between these two? It is 90 minus theta. So put 90 minus theta directly. Okay, 90 minus theta directly. So it is what? Cos 90 minus theta is what? Sin theta. So it is r sin theta. The answer is correct. R sin theta. So when you're doing these exercises and examples for your convenience, always make it cos, like cos. You put all the cos and theta. For that theta should be the angle between the directions of the force and the which angle we are going to make the component of that such force. Okay. So please remember these tips. It will be helpful to you. And so, okay. Thank you very much. We will we will continue in the next class with a new chapter. It's mechanics. So if any doubts or anything, you can put in the comments box. We will discuss in the next class. So we will start with the new chapter. It's mechanics. Please share with your friends if you have get benefit this video. Okay. Thank you very much.